Good morning, class. Today we are going to study about exponential notation or scientific notation, and in UK they are calling it standard form. Now, what is the scientific notation or exponential notation? This is a convenient way of writing very large numbers or very small numbers. Okay, let's have now class converting scientific notation to ordinary numbers. Our ordinary numbers should be here. All of these are exponential numbers or notations. So number one, we have the negative 3 here. Find the negative 3. Where is the negative 3? So the negative 3 is here, class. Negative 3, negative 3. Then, to put this number into ordinary numbers, we need to go here because this is for ordinary numbers. So from here, this one is there, we are going here. And to go to our ordinary numbers, we are going to move the decimal point of this to the left. And to reach here, how many? From here, 1, 2, and 3. So we are going to move this number here, decimal point of this number here to the left, 3 to the left. Okay, so here, let's have that one as 2, right? Again, that one is 2. Where is the decimal point of this one? Here, right? That one there. So we will move 3 to the left. So here 1 and 2 and 3. That's negative 3. Then put decimal point here and add 0 here. 0 there. So that is 0.002. But it's better to have a 0 there. It is not counted, class. It's only the 0 here. But it's better to put the 0 before the decimal point in any decimal numbers. So here our final answer is 0.002. Okay, let's have times 10 to the 5th here. Alright, find here the 5, positive 5. Oh, it's here. So what are we going to do with the 4.5 here? I'm going to put, we're going to move the decimal point of this one where? To the right, so that we reach the number here, to the right. How many? 5, because this one is what? 5, to the right. So we are going to move here to the right. 1, first here, 2, 3, 4, and 5. Then we have there. Oh, what about this blanks here? You place the eggs, the zeros. Okay, here and here. So the decimal point is now there. Okay, so we have 450,000. Okay, it's like that. So have the decimal point there. You can remove the decimal point. This one is only to count 1, 2, 3. Count 1, 2, 3. So 1, 2, 3, 4. 1, 2, 3, 4. Remove that one if you want. It's 450,000. You can check. Negative exponent means a small number. Small number? Yes, decimal number. Positive exponent, is it a big number? Yes, it's 450,000. Okay, I'm going to erase this one, plus. Let's have number 3. We just copy. Okay, we do not know where this one will move. And then go to positive 2. Where's the positive 2? Here. So where are we going? To the right, to the number here, to the middle. So we are going to move the decimal point of that one to the right, 2. So we are going to move this one from here, 1 and 2. So this one is 125. Is that a big number? Yes. The sign? Positive? Yes. Okay. Number 4, right? The one here. Where's the decimal point? 1. It's there. 1 point. Okay. So we have 1 and point here. That's the one there. So locate the negative 2. Where's the negative 2? Oh, it's there, negative 2. Move it to the left. So we move it to the left. How many? 2. So here, to reach that number there, so we have 1 is here and 2. Decimal point here. And then you place 0 there. And then place another 0 here. So we have not counted. 0 is counted. And then 1. Do you want to add 0? Yes, you can add 0, 0, 0, 0, 0. It doesn't matter. Here, do not add 0 because it will become 1250. Here, do not add 0. Here, you can add 0. 20, 200, yes. Okay, number 5. 2.7. Okay, I'm going to write for 2.7. So 3. Find the 3. Where's the 3? The 3 is here. I'm going to erase this one. The 3 positive is here. So we go there to that number. So how many? We are going to the right 3. So from here we go to the right 3. 1 and 2 and 3. Decimal point here. Add 0. Add 0. So your answer now is 2,700. After, so let's have that one, number 1. This one is 57,500. It's a big number. Okay, we know that. And this 57,500 is an ordinary number. So this ordinary number is here. Here. Okay, it should be here. Now, we are going to write that 1 times 10 to the third. And where is the third? The third is this one because there is R for all the exponents. The third is here. So you move the decimal point of the number to the left. For number 1 to the left by how many? By 3. So here we will move the decimal point to the left by 3. But where's the decimal point of this 57500? So we know there is no decimal point and then the decimal point is there. Then let us move that one 3 to the left. So we have 1 and 2 and 3. So it will be 57.5. So we write here 57.5 times 10 to the third power. Number 2, 0.0024 is here. I'm going to move this one here. So that one is negative 5. So what should be the base here? Negative 5 is there, negative 5. So from here, because decimal is our ordinary numbers, we are going to move the decimal point of this one to the right. To the right by how many? Because that one is negative 5, that one is negative 5. It's obviously 5. So let us move this one 5 to the right here. So and then we write here. So here it's 1 and 2 and 3 and 4 and 5. So we add 0 here. So you see it's 240. So it is 240. Now you see plus, this one is not in the standard form. Why? Because the decimal point is not here. It's not here, but there. Okay. Number 3, 0.8. So 0.8 is here. Remove that. And that one is to the third. Where's to the third? This was positive, so here. So we are going to move the decimal point of this 0.8 to the left. How many? 3 to the left. So from here, so I'm going to write again the 0.8. 1 and 2 and 3. So it's here. We need to place 0 here, 0 here, 0 here, and place 0 there. So this one is not counted. We have 1 and 2 and Okay, let's have 12. The 12 is here. This one is different. We are going to find times 10 and then exponent here, and this one also. The 10 is missing, so we're going to find exponent here. 12 is here. So our 12 is here, and it becomes this one. So the decimal point of the 12 is here. Then suddenly here, the decimal point is here. So the decimal point moves to the left here. So when the decimal point of this one moves to the left, what will be the sign of the exponent? It will be positive. So you know it is positive here. By how many? Then we count. From here, start here. So we have 1 and 2 and 3 and 4. So we write there 4. And then remove the positive. So it's a positive 4. So it's 0.0012 times 10 to the 4th. Right, 135. Okay, the 135 is here. We have here. So it moves to the right by 1. 1. So 0. So if that is 1, so from here to the right, it will be negative 1. So we place it negative 1. Okay. Right, number 6. We have now our exponential notation, and we are going to find the ordinary numbers, and these are not in standard form. Locate the 320 exponent, it's there, the 320 there. Let's have the 4, it's easier, this one is easier. Positive is here, and we are going there to the ordinary numbers. So we need to move the decimal point of 320, let us write first 320 here, to the right. By how many? By 4. 1, 2, 3, 4. Move this one 4 to the right. So we have 1, start there, not here. 2, 3, and 4. Decimal point. And put the 0 here, 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 and here. So our answer is 3,200,000. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 3,200,000. Okay, number 7. Negative 2. Where are negative 2? Here. And we are going to write this one in ordinary numbers. So we go here. We need to stop here. So we start here. So we are going to the left. From here. So we write that point 25 first. Then we come 2 to the left. So here 1 and 2 decimal point 0, 0. Then add 0 here. So our answer is 0.0025. That is the ordinary number of this number 7. Okay, let's have this one. This one is 100. Okay. So let's have 100 here. 100. Right, first. Where's the decimal point of 100? Here. Okay. Let's have the negative 2. Where's the negative 2? Here is the negative 2. So we are going here to our ordinary numbers. So we move the decimal point of that one to the left. How many? 2. So from here, we move it to the left. 1 and 2. So our answer here is 1. And then number 9, we have, what is the exponent of 10 here? There's no exponent there. It is understood to be 1, positive. So we are here. Now we write the point 10 here. Okay. Now this is 1 because we don't see any exponent there. And we are going there to the ordinary number 1 to the right. So 1 to the right from here. 1 to the right, and our answer is also 1 here. And last we have 24. We write here that 24. Decimal point is here. And then where's the negative 1? The negative 1 is here, and we are going here to the ordinary number, so we move it to the left, 1. So from here we move 1, and our answer is 2.4. Okay, let's have the application class of our scientific notation. Let's have addition. We have here 3.25 times 10 to the second plus 4.5 times 10 to the third. How do we add? So let us review our algebra class. In our algebra, we have x plus 2x. Can you add the x plus 2x plus? Yes, because this x and the x, they are like terms. Then we add the numerical coefficient of this one and that one, because positive and positive we add, we have 3x. Now if this one is to the second power, they are now unlike terms. So we cannot add the 1 here and the 2 there. So it's the same, we cannot add. So the answer is x plus 2x squared. How do we add the numerical coefficient? This exponent here must be the same. X squared, 1x squared, and 2x squared, they are like terms. So we can add the 1 here and the 2 there. So you have 3x squared. So here also class, the exponents must be the same. Either this one is 2 also, so we can add this and this. Or this one is 3, this one is 3. If we are going to write this one in algebra, we have 3.25x squared plus 4.5x squared. What is this x squared? This is our 10 to the second, and this one is 10 to the, why do we have cube here, cube there, like that class. So we cannot add the 3.25 and the 4.5. So in our solution, we must make their exponents the same, so they will be like terms. This one is not the x there class. 3.25 bracket 10 to the second. That x there is the 10. Okay? Just to give you an idea. Okay, let's have here. So let's write both of them to the second power. So here, I'm just going to write 3.25 times 10 to the second power. Now also this one, we are going to write this one to the second power, times 10 to the second power. But we don't know this one because the decimal point of this one will move either to the right or to the left. We know it's going to move to the right or to the left only one, because this one is 3, this one is 2. So we are not writing this one yet here. So the answer here will be times 10 to the second, because they are like terms, like the x squared there. Now let us change this 3. Where is the 3? It's positive exponent, so these are all 4 exponents. So this 4.5 is here. Now we are going to make 3, the exponent of 3, 2, like this one. So the 2 is here. So we need to move the decimal point of this one from 3 to 2. So we are going to move it to the right, one only. One movement of decimal point from this to there. So what happens to this one is, it will become 45. So when you arrange that one, the 45, this one is the arrangement. We must arrange them because we are adding decimals. So the arrangement of that one is 45 times 10 to the second. We can now add. This one is 0, 0. If you want to add 0. So when we add, we have 5 here, we have 2 there, decimal point, and we have 8, and we have 4. What is this one in ordinary numbers? In ordinary numbers, if we are going to write this one, this is equal to times 2, or is that one? And we are going here 1, 2, so we have 1, 2, so our answer is 4,825. Okay, that is our answer here. What about if we make this one like 3 and they are both in the third power? So here, just going to write 4.5 here, 4.5 times 10 to the third, and this one is times 10 to the third also. So our answer here will be times 10 to the third, because they are like terms. Now, we need to replace this one. Where's the 2 here? The 2 is here. And we are going to make this one 3. So we will move 2 to 3. So we are going to move the decimal point 1 place. So from here, it happened to this one to the left, to the left, 2 to 3 is to the left, 1. So from here, it will become 0.3 to 5, right? So we have 0.3 to 5 here, times 10 to the third. I'm going to place here, times 10 to the third. So it will be centered here, times 10 to the third. So I have here, put the 0 there, and then 0 here, and then 0 here. Decimal point, decimal point, decimal point, and then we add. So here we have 5 plus 0 is 5, 2 plus 0 is 2, 3 plus 5 is 8, and 4, 0 plus 4. So we have 4.825 times 10 to the third power, so 1 and 2 and 3. So our answer is the same, 4.825 here. So check and check, and that is how to add. And in subtraction also class, we must make sure that the exponents are the same.